Diksha Didi. Good evening.
Hi, good evening. Sorry, my network disconnected yesterday.
It's all right. No problem. So we can just continue there from the break statement only, from where you got disconnected, right? So we were on
Okay.
jump statements in C++. So let's just continue from there only. So these statements are used in C or C++ for the unconditional flow of control throughout the functions in a program. So basically, if your condition that you give to the loop that when to break, if you want to break before the condition is met, then you can to jump the loop, or if you want to break out of the loop, or you have to do some other like jump action, then we can use jump statements in C++. So there are four types of jump statements in C++. We have break, all right. We have continue, right. We have go to, right. That will be new for us, and we have return, right. So we're gonna start with the break jump statement. So this loop control statement is used to terminate the loop, right? So it terminates the loop as soon as some condition meets. So as soon as a break statement is encountered from within a loop, the loop iteration stops there and control returns from the loop immediately to the first statement after the loop. So for example, over here, whenever you break, whatever will be there after the loop, it will just come out of the loop, right? So this loop will completely end at that moment. Alright, so here's the syntax of the break keyword. You just have to give break, right? So the break keyword is just like break. So basically, break statements are used in situations when we are not sure about the actual number of iterations for the loop, or we want to terminate the loop based on some condition. So if you want to break the loop based on some condition, then we can use the break keyword. So here we have the break statement flow diagram. So there's a loop condition expression. If that is true, the loop code block, right? And the loop condition expression will continue executing. At some point in the loop code block, right, there may be the break statement. So once the break statement is encountered, then the statement of the loop after the loop block is executed. Or if the condition expression evaluates to false, then also it goes to the statement after the loop block. So there are two ways through which you can get out of a loop. You can get out using the break statement, that in the code block, if you give some the if you give the break statement somewhere between the code block, then it will go on the statement after the loop block. Or if the loop condition expression is false, then it will go on the statement after the loop block. Alright, so here's the syntax, or here's an example of the break keyword. So we have two methods. We have the find element and we have the main method. So we are gonna start with the main method, and then we're gonna look at the find element method. So in the main method, we have an array, integer array, right? So we have an integer array whose value is an normal array, right? An integer array with six elements: 1, 2, 3, 4, 5, 6, right? And then we are specifying the number of elements is equals to 6, right? And then we have the key equals to 3. We're gonna see why we need the key and the number of elements, right? We have to pass it to find element, right? So we have to pass it the array, we have to pass it the number of elements, and we have to pass it the key, right? So in find element, it's receiving an array, it's receiving the size of an array of the array, and it is receiving the key. All right, so we are going to see the usage of key, right? So we are looping on the array. We are saying for int I equals to 0, I less than size I plus plus. So size value is 6. So we are saying I equals to 0, I less than 6, I plus plus. So first i's value will be 0, then 1, then 2, then 3, then 4, and so on till it's not less than size, right? Then once it's not less than size, it will break. So it will check if array I equals to key. So first it will check if array 0 is equals to key, then it will check if array 1 is equals to key, array 2 equals to 3 key, right? So array I right now is, it will check array 0. Array 0 will check if the 0th element of the array is equals to the key value. So key is 3 and the 0th element's value is 1, right? So this will be false, so this will ignore it and it will go back over here. It will then increment the value of I, right? And then it will check this condition, and then it is gonna check array and 1 is equals to key. So it will check array 1 equals to key. So we're checking 2 equals to 3, that is false. So it will go back, it will increment I. So now i's value is 3, right? This condition is meeting over here because 3 is less than 6, right? So it will go and it will check, sorry, i's value is 2. I said 3 over here. I's value is 2 now, right? So it will check array 2 equals to key. So the array 2 is 0, 1, 2, right? So array 2 is 3, right? So it will check 3 equals to key. Now 3 equals to 3 is true, so it will go in, it will print element found at position, and then it will say I plus 1, right? So why are we doing I plus 1? If we had said I, we would have just got the index of the element where the element was found, right? But we want to give its position, right? We don't have to tell at which index the element was found, we have to tell its position. So we are saying I plus 1, as it was on the third position, it's the second index, 0, 1, 2, it's on the second index, but the position is 3, that this is the first position, this is the second position, this is the third position, right? So we are saying element found at position, and then we are saying I plus 1. So I was 2 at that time, so plus 1 3. So element found at position 3, and then it will break out of the loop, it will not further check for a match. Once it breaks out, then this function's work will be over, right? And in the end, what we'll get on the screen, we'll get element found at position 3, right? So we are getting element found at position 3. So I hope this example is clear.
Yeah, it's clear.
All right. And one more thing to note, over here we have given void. So void is basically just telling that there's no return keyword in this, so we are not going to return anything from this function, right? That we saw in the basic course also. Now before continuing, I want to go back to the switch statement once, and I think I need to elaborate more on the switch statement. So over here in the switch statement, we are just gonna have a recap. So it's basically very similar to if and if else if, right? It's very similar to the if else if ladder, right? So we have switch var. So we are saying switch 2, right? So everything is working fine over here. We are saying case 1, right? And this is false because the expression is not equal to the value given after the case. But in case 2, it finds a match as 2 is equal to the expression given over here, right? Var's value, that is 2, right? So this is a match, it will print case 2 is executed, and then it will break out, right? So we are gonna get case 2 is executed, right? So it's gonna work normally. But what if we remove all the breaks? Over here I mentioned that it will keep on checking for other cases also, though it is not required. But it will also execute the other cases just after this case match. So once this case has matched, like case 2 has matched, right, it will go on executing the cases further, right? If even if the cases don't match, it will execute the block of code inside each case after the match, right? So after case 2 we have the default block. So though it should not go in the default block, but when not giving break, it is this block is just after the match, over here the case matched over here. So this block is after it, so it has executed that also. So you'll get case 2 is executed, and we'll get default case is executed, both, right? Though we only wanted case 2 is executed. Now for example, we have case 3 over here, right? Case 3, and case 3 is executed. Now the match will be with case 2, it will go in and it will print case 2 is executed. But then whatever is there, whatever blocks of code are there after the match, right, everything will get executed. So though case 3 is not a match, still it will go in case 3, it will execute whatever is there in case 3, and then it will go in default also, and it will execute whatever is there in default. Alright, so it's showing case 2 is executed, case 3 is executed, and default case is executed. It is showing all the three things. Now what if we had 4 over here, right? 4, case 1, case 2, case 3, all of these are not a match. So it'll go in default, it will print default case is executed, right? But if we give the default case above, right? So if we give the default case up, right? So then what will happen? Let's see. So when giving the default case above, case 1, case 2, case 3 all were not a match, right? So it went in the default case, is executed the default case block, and whatever blocks of code were after the default case, all of them got executed. So default case is executed, case 1 is executed, case 2 is executed, and case 3 is executed. All are shown on the screen, right? So this is some unusual behavior when you don't give break after the block of code. So if you don't want this behavior to happen intentionally, then you should always give break after the block of code in the switch statement. So this is what I wanted to tell in the switch statement, and I hope now the switch statement is more clear. Hello? Hello?
Am I audible?
Yeah, now you are. Yeah, I hope the switch
Sorry, I think the mic has some issue.
Oh, all right. No problem. I just wanted to confirm if the switch case now is clear.
Yeah, it was clear.
All right.
Thank you.
So now we are on the continue jump statement. So this loop control statement is just like the break statement. It's very similar to the break statement. So the continue statement is opposite to that of the break statement. So it's opposite to the break statement. Instead of terminating it's similar, but it's also opposite to that of the break statement. Instead of terminating the loop, it forces to execute the next iteration of the loop. Right over here, we give uh, break, right? So we give break over here. Instead, if you would have given continue, then it would have ignored whatever was there after the continue keyword. So the for in the for loop, whenever or in a loop, whenever you give continue, it ignores whatever is there after the continue statement, and it will just not execute whatever is there after the continue statement and go back and move on to the next iteration. Unlike break, where when once break is encountered, it just terminates the whole loop. So it forces to execute the next iteration of the loop. So as the name suggests, the continue statement forces the loop to continue or execute the next iteration. When the continue statement is executed in the loop, the code inside the loop following the continue statement will be skipped and the next iteration of the loop will begin. So the syntax is just continue, right? And here we have the flowchart of the continue statement. So we have the loop body, right? We have a condition, right? So if that in the loop body, if the condition is true, we give continue, right? So whatever is there after continue, nothing will get executed, and uh, so the remaining part of the loop body that was there after continue is not executed. It is skipped and it goes back to the loop body, right, for the next iteration, right? But if this condition was false where it led to continue, then it would have basically executed the remaining part of the loop body normally, right? So when continue is encountered, whatever is there after continue keyword inside the loop, none of that gets executed. Alright, so here we have an example of the continue statement also. We have I equals to 1, I less than equals to 10, I plus plus. Right, so when I will be equals to 6, we'll continue, else we're just gonna print I. Right, so gonna get, first we're gonna get 1 because then we'll get 2, then we'll get 3, then gonna get 4, then 5. Right, but then when I equals to 6, I will be 6, it will check 6 equals to 6, that will be true, right? So it will continue, right? So it will just continue this part, right? And though continue is not doing anything right now, as when this condition is true, it will never go in the else statement. But if we had it like this, right, if we have it like this, then it will check if I equals to every time it will check if I equals to 6, then it will continue, right? But if it will not be equals to 6, it will execute the remaining part of the loop body, that is this part, right? So it every time first when I is 1, it will execute 1, then 2, then 3, then 4, then when it is 5, it will check 5 equals to 6, that is false. So we'll just continue with executing the code. So 5 will be printed. Then when I is incremented, it goes in, it will check 6 equals to 6. Right now that is true, so it will go in this, it will continue, right? So it will it encounters the continue keyword. So instead of going over here and executing the number or printing the number, it just skips whatever is after there after continue, right? And it will go back to the next iteration, right? So we'll get 1 2 3 4 5 7 8 9 10. All right. So this is what's happening over here. So if you create a variable in if else in C++, it will be local to that if else block only. So you can use global variables inside the if else block, right? So if the name of the variable you created in the if else is as same as a global variable, then priority will be given to the local variable. So here there's something about the if else block. So over here, if you have a global variable like gfg, right, that is equal to 0, and we are printing it before if else block is, we are printing gfg. Now if 1, right, so 1 is true, so it will go inside the if statement, it will create gfg for this if block, and now it's saying int gfg equals to 100. So this is a new local variable of the if block. It won't change the value of the gfg variable outside the if block. It is a local variable to the if block, right, and it is not accessible outside this if block. It won't affect other variables outside the if block, right, and it is not accessible outside the if block. So this gfg is only available to the if block only, and it won't change the gfg variable that is outside the if block, right? And then it will print if block gfg, right, and then it will come out, it will print after if block, and then it will show gfg and it will return 0. So if first we'll get before if block, if else block we'll get 0, then we'll get if block 100, and then we'll get after if block 0, right? So we're getting before if else block 0, if block 100, and after if block 0. So I hope the this concept of local variables inside the if block is clear.
Yeah, it's clear.
All right. So next we are gonna go to the go-to statement. So this is also a type of jump statement. So the go-to statement in C++, also referred to as the unconditional jump statement, can be used to jump from one point to another within a function. So this is for within a function. So if you want to jump from one point to another point within a function, you can use the go-to statement. So the over here we have the syntax. So we have syntax 1 and we have syntax 2. In syntax 1 we are saying go to label 1, or we are saying go to label, right, and wherever it finds label it will go to that block of code, ignoring everything else in between, right? So it will just go to the label, right, and execute whatever is there in the label. Another syntax is when you have label defined on top, right, and after that you say go to label. So as it is defined on top, it will continue the it will ignore the code between it, and it will just go to the label to execute that block of code inside label. So over here you had label below it, right, and you said go to label above it, and over here you define the label above, right, and you're saying go to label below it, right? So these are the two types of syntaxes that we're gonna see also. So in the above syntax, the first line tells the compiler to go to or jump to the statement marked as label. So the first line tells the compiler to go to or jump to the statement marked as label. So over here they're talking in syntax 1, right? So this is telling that uh, we have to go to the label, right? We have to go to the jump to the block of code that is marked as label. So here label is a user defined identifier that indicates the target statement, right? So it's basically a user defined identifier that indicates the target statement. So the statement immediately followed after label is the destination statement, right? So we're gonna see all of that in detail when we look at a real code example, right? So the label can also appear before the go to label statement in the above statement, in the above syntax. So over here we have a flowchart. So we have start, we have statement one, right? And before executing the other we have before executing the other statement, it goes and says go to label 3. Now label 3 is over here, so it just goes to the label 3, and it executes whatever is there in the label 3, right? And in between the label 2 and whatever code was in between was ignored, right? So it directly went to label 3, right? And it jumped to label 3 and executed the block of code. So over here we have an example. Over here we have the print numbers method, right? And we have the main method. In main method we are calling the print numbers method, right? And then we are saying int n equals to 1, right? Then we have a label, right? So the label is a normal block of code over here, right? This block of code will normally get executed, right? It is gonna normally get executed, but whenever someone says go to label, then it will jump to this block of code also, right? So this is this will execute in the program flow. It will execute normally like any other block of code, but it will also when someone says go to label, it will just directly go to the label that we have defined over here. So in label we are saying cout n, right? So we are printing the value of n, we are incrementing n, and we are checking if n is less than equals to 10. So after incrementing n, we are checking if n is less than equals to 10. If it is, then it will go to label, right? And it will go back to the label, right? So it is, the program is not over yet. It will go back to the label to execute it further. After going back to the label, it will execute uh, it will execute the value of n, it will increment the value of n, and if n is less than equal to 10, it will go to the label, right? So this is how this is now working kind of like a loop, right? So till n is less than equal to 10, it is again and again going back to label, right, to execute the same block of code again and again. So it's working like a loop over here, right? So we're getting 1 2 3 4 5 6 7 8 9 10 from this block of code, right? So we are getting one first, right? Then it is incremented, then it is printed, then it's incremented, then it's printed. So till once label's value is 9, right? Or let's say 10, so it will go in, it will print 10, it will increment, it will say 11, right? So it will check if 11 is less than equal to 10. So now this is false, so it will not go inside the if statement and not execute go to label, and it will just finish up the function, right? So in the end we'll get 1 2 3 4 5 6 7 8 9 10 from this function. Alright, so we're getting 1 2 3 4 5 6 7 8 9 10. So is this part clear? The go to uh, the go to keyword, as this is new for us.
Yeah, it's clear. I'll just read it once more
Or
after the class.
alright, alright. If you have any doubts, you are free. Feel free to ask.
No, I don't have any doubts. It's
Alright,
clear, thank you.
alright. So next we have the return statement. So in the return in C++ returns the flow of the execution to the function from where it is called, right? So this statement does not mandatorily need any conditional statement. So as soon as the statement is executed, the flow of the program stops immediately and returns the control from where it was called. The return statement may or may not return anything from a void function, but for a non-void function, a return value must be returned. So it's basically very similar to break, right? So wherever you encounter return, right, over there the execution of the block of code will stop, right? And but the different thing is that you can return some value, so that value can be later used in break. When breaking out of the loop, you can't return any value, right? So it will just break out of the loop and continue the program execution. But when you return some value, it will break out of the block of code, right? And it will give us some value that we can use further in the program, right? So we have already seen the return keyword in our basics course also. This is a quick fresh revision, right? So the return statement may or may not return anything for a void function. So it's saying may or may not return anything for a void function, but for a non-void function a return value must be returned. So over here, here's the flowchart of return. So we have integer increment in which we are taking n, right, and we are returning some number, right, and we have to return some number as we are returning an integer value over here, right. Now we are returning that. So where this function is called, right, the return value can be used, though we are not using it anywhere right now, but it can be used, right. So the program, once it encounters return, right, the program control is shifted from the function to over here, and whatever you give after return, like you give some statements in the function after the return statement, that won't work. So here's the syntax: return, and then we have to give some expression that will tell what to return. So over here, here's the block of code. We have integer sum, right? So we have a sum method that will return an integer value. It is taking in two integers, a and b, and in this we have s1 in which we are saying a plus b. So whatever two values are passed, we are just adding them and we are returning them. In the print function, we are just printing whatever is passed to the print function. It is just saying the sum is, and then it will say whatever is passed, right. And we have num1 equals to 10, num2 equals to 10, and then we are calling sum num1 num2, right. So it will add both the values and it will return the added value. So it will return 20. Now 20 is being saved in sum of, then we are passing sum of to print, right. So the print function is taking sum of, and this is a void. We are giving over here return, we are giving the return type void. So this function is meant to return nothing, or it is meant to return void, right. So if you don't give this return statement that you give that the website is giving over here, the return statement is not mandatory in your void functions, right. And over here, when the sum is passed, right, then the sum is, and whatever sum passed will be shown. So the sum is 20 will be shown on the screen, and uh, this was the program. So we're getting the sum, we'll be getting the sum is 20, right. And one more thing over here, after return s1, if we give some thing like cout high, then this won't work, as after return whatever you give won't get executed. So the sum is 20 only we are getting, right. We are not getting that high that we see outed, that we try to print after the return statement. So I hope all the jump statements, the if else ladders, and all switch statements, everything is clear till now. So we can move on to the next topic: basic input output.
Yeah, they're clear.
All right, great. So so now we are on the basic input output in C++, right. So in C++ we could use the function free f reopen, file reopen, to redirect an existing file pointer to another stream. The prototype of f reopen is given as, right. So before starting this concept, we have to discuss some things. First we are gonna see streams and then buffer, right. So buffers, what they are: buffer memory. We have like before when we do cout, right. So before showing on the screen, right, before some the text that we want to show going on the screen, it first goes to the buffer memory, then it goes on to the screen, right. When we learned file modification and file handling in C++, then what was happening: first whatever we wanted to write into the file, that went to the buffer memory, and then it went to the file, right. And what is the buffer memory? Buffer memory is the closest memory to your processor, computer processor, right. So first everything, like if you want to print something, you want to take the input from the user, that first goes to the buffer memory, and then it goes to your desired location, like the screen, or to the program, or to the file, or someplace, right? So IO redirection, what we are gonna talk about is how to change where the things go, right? Basically, in basic language, like if when I'm using the cout method, how to use the cout to actually write in the file, right? So we're gonna say redirection. So we're gonna change the streams of objects, right? So the streams of objects are basically where it goes from this is called a stream when it when to, like, for example, cout. This is a stream where first it goes to the buffer memory of cout, and then it goes on the screen. Cn is also a stream object type. Like, first it takes the input from the user, it goes to the buffer memory, and then it comes to the program, right? So we are going to see how to change the stream, like how the cout stream, right, that will give the text to the screen. Instead of that, how can we manipulate that stream to actually write into a file, right? So if you have a file X and we are using cout, we're gonna see how we are able to write in that file using cout, right? In this chapter you're going to see IO redirection, that is basically this concept of redirecting or changing the streams of other stream objects. Alright, so in C, right? So in C, we could use the file reopen function to redirect an existing file pointer to another stream. So, this is saying that we can use f reopen in C to redirect a file pointer, right? So the pointer that will write to the file, that f reopen can be used to basically change. To redirect the existing file pointer to the, for example, another stream, like this screen, right? So when using, here we have some example only, that when using f reopen, this using f reopen, what you can possibly do, one example is that instead of writing to the file, you are writing to the screen, right? So that is changing of streams, right? And it's basically you're redirecting an existing file pointer, right? So something that was previously pointing to the file to another stream, right? That is the screen, right? So to the cout stream, where it first goes to the buffer memory and then to the screen, right? So a prototype of f reopen is given as like file star f reopen, right? Where it takes in the file name, it takes in the mode, like write mode, read mode, or whatever, and then it takes the stream to which we have to redirect it to. So over here we are giving an example, we are using f reopen, we are saying text file.txt, right? So we are giving it the file, we are saying the write mode, and we are redirecting the stream to standard output, right? So when we will try to write to text file.txt, it will actually write to standard output stream, right? So it will actually output it on the screen. Basically over here, whenever we will be using some method to write to text file.txt, that we have redirected from f reopen, and it will actually write to the screen, right? So we're gonna see that live in C++ also, right? So while this method is still supported in C++, this article discusses another way to redirect IO streams. So we are going to see, instead of f reopen, we are going to see another way to redirect IO streams. So C++, being an object-oriented programming language, gives us the ability to not only define our own streams, so we can also define our own streams in this, right? But we can also redirect the standard streams, like streams that write to the file, streams that write to the screen, streams that bring in input from the user, etc. So thus in C++, a stream is an object whose behavior is defined by a class. So in C++, a stream is an object whose behavior is defined by a class. So thus anything that behaves like a stream is also a stream, right? So anything behaving like a stream is also a stream, is also considered to be a stream. So here we have some stream objects, standard stream objects in C++. So they are mainly of three types. We have iStream, OStream, and IOStream. So iStream is the stream objects. The stream object of this type can only perform input operation from the stream. So iStream is basically taking in the input from user, then it goes to the buffer memory of your computer, and then it comes to you. OStream is where you give some output to the screen, right? Or you perform some output operation. So you want to output something, it then goes to the buffer memory, and then it goes to your your screen or the file, right? And one more thing, buffer memory, I wanted to say, frequently it only saves the code or statements that are frequently used, right? Or the data code statements that are frequently used are also saved in the buffer memory of your computer, right? And final stream, the third main stream is IO stream, that can be used for both input and output operations, right? So it can be used for both input and output operations. So all these classes as well as file stream classes derive from the classes. So all these classes as well as file stream classes derive from this classes iOS and stream buff, right? So these all are derived from the classes iOS and stream buff, right? So we are going to see them in detail when we are going to get to the example. So thus file stream and IO stream objects behave similarly. These are very similar. File stream objects read and write to files. IO stream objects read data from the screen and write data to the screen, right? So all stream objects also have an associated data member of the class stream buff, right? So we're gonna see that. So simply put, stream buff object is the buffer for the stream. So stream buff object is the buffer of the stream, right? That stream buff object will be the buffer for cout, right? Cin's buffer of stream the stream buff object is the buffer for this. The Cin's stream buff object, it will be the buffer object for this Cin stream, right? And so simply put it in this words, that stream buff object is the buffer for the stream. So when we read data from a stream, we don't read it directly from the source, right? But instead we read it from the buffer which is linked to the source. So from the source, when we are reading, the source sends the data to the buffer, and then it is read by the program. Similarly, output operations are first performed on a buffer. So whatever we are wanting to output on the screen or on a file, right, those are performed on the buffer, and then the buffer is flushed, right? So then what happens, the buffer is flushed, right, and it is returned to the physical device when needed. So C++ allows us to set the stream buffer for any stream. So the task of redirecting the stream simply reduces to changing the stream buffer associated with the stream. So what happens? It allows us to set the stream buffer for any stream, right? So you can set the stream buffer for any stream. Now, when you change the stream buffer of any stream object, like if I set this cout object stream buffer to be the files stream object, right? So file writing stream object, I'm changing to cout stream object, or we are changing the cout stream object to the file writing stream object. Then what will happen if we change, for example, the file writing stream object to the cout stream object? So whenever we sorry, I'm saying stream object, I meant buffer object. So if we change the files buffer object to cout's buffer object, then whenever we'll try to write to the file, that will write to the buffer. So C++ allows us to set the stream buffer for any stream. So the task of redirecting the stream simply reduces to changing the stream buffer associated with the stream. So from the file stream, if you want to write to the screen, right, then we can just change the buffer of the file stream, and that will do the work for us. Similar vice versa, right? So thus, to redirect the stream A to stream B, what we need to do, we just need to change the buffer. We just need to interchange the buffer of both the stream objects, and that will basically do the work for us, right? And we are gonna see this more in detail tomorrow in the next class, as the class is already about to end, right? So
Okay.
I hope
Yeah.
the thing of streams and all is clear till now, as it's an advanced concept. If you have any doubts, please feel free to ask. Right? Thank you.